All right, test time to see if things happen when things are done to things. CableMod's new StealthSense technology effectively eliminates the need for sense wires for your 40 series GPU. StealthSense features a hidden bridge which signals the GPU that a full 600 watts is available, all without the need for fragile sense wires that can easily be dislodged, leading to a black screen and 100% fans. To see the full spec list and power supplies supported, follow the link in the description below. Okay, so actually I got an email recently that brought up a subject that I've been wanting to test that I forgot all about. Which is going to be whether or not the orientation of your graphics card affects the cooling of it. And specifically, we're talking about vapor chamber cards. Pretty much every graphics card today is a vapor chamber cooler. So if you're not familiar with a vapor chamber, what it is it uses phase change built into those copper pipes that have a kind of a wick material in there, as well as a fluid. And what happens is, as the fluid gets hot, it starts to turn to steam. Then that steam wicks itself away from the heat because it pressurizes and moves away. Then as it cools down, it starts to turn into a liquid form again, move back to the source of the heat, and repeats that process very, very quickly. So heat pipes were the natural progression of just having a chunk of metal with fins in it and a fan, where you have to deal with conductive temperature, so that the heat would absorb through the metal and then get taken away. It's a very slow process versus the wicking features of vapor chambers. It got me thinking, like, when this email is very legit, because if we're talking about a card that is typically designed to go like this is the traditional orientation of graphics cards. As time went on, we started seeing more vertical mounts, right? So now you got to ask yourself if that vertical mount adds any sort of gravitational issue where gravity can affect that wicking process on whether or not it's going to be able to effectively and as efficiently move the heat away. Now, see, this is the kind of thing that, for the most part, wouldn't be much of a difference. If the card is horizontal, we're just dealing with horizontal surfaces and not having to overcome humps or any sort of gravity that could potentially, which is what we're testing, to see whether or not it would have any effects on the temperatures. But you've got really different orientations for graphics cards now in different, like, niche cases. Like, for instance, the SUP-01 puts the graphics card like this in there. Now we're talking, with the heat and the GPU being more at the bottom of the card down here, a lot of distance that has to be traveled against gravity. Now, I'll be honest, I don't know how much gravity would have an effect on something that is being pressurized like that. I know it can absolutely have an effect on water flow. That's why it's called head pressure. And it's actually measured in column inches, which means how far up a vertical column of tubing could the pressure of the pump push it before the weight of all that fluid and gravity stops it from being able to push it any farther. We're not dealing with distances like that here. Another example that people like to use kind of incorrectly is convection-assisted cooling. Now here's the thing, convection is a very weak process, a very weak force. Convection is the natural rise of heat from something. So when people will put a fan on the top of the case and say, oh, it's convection assisted, the moment that fan blade starts turning, it is overpowering any convection. And at that point, it's no longer convection assisted. The convection is being assisted by the fan, which at that point is just overriding convection altogether. It's now just airflow. So that's a very weak force. I don't think it'll really have much to play with this. Or it won't have as much to do with this type of testing, but it's worth mentioning. So what I'm gonna do today is I'm gonna use my riser cable. I'm gonna use my 4090. I'm going to use my AM5 system here with a 9800X3D in there. CPU doesn't matter because we're using a GPU bound test. I'm gonna set the fan speed to a consistent speed at like 80%. I'm also gonna make sure that I have a very temperature controlled room here. I'm gonna also be logging ambient temperatures, so you guys can see the ambient temp curve along with any changes in the GPU temp. We have to account for ambient temperature because if the ambient comes down 3 degrees, the GPU temp can come down 3 degrees, which means, hey, one orientation was 3 degrees cooler than the other, but if that was 3 degrees cooler at the time, then it's a wash. There's no improvement. So I'm gonna be checking all that, making sure it's nice and consistent, logging it with my KTH monitor here from Elmore. I love Elmore Labs. It is so many cool tools. I even got new ones. Look, Phil, show them the new one. The PMD2. My spaghetti monstrosity there. But I love being able to test this sort of stuff now. So the orientations I want to test is standard. So that would be backplate facing up horizontal. Test bench, my test bench mode essentially is vertical mount. So we're gonna have vertical mount, plugs down, horizontal, vertical, and then the other way, where we're gonna have GPU die at the top, pipes on the bottom. I don't think that's gonna have much of an effect, but I think we might potentially see a difference between horizontal and vertical. But like I said, a lot of cases now are starting to allow options to mount your GPU this way. So with that said, let me go through all the tests and put together all the charts and crap, and then we'll see if anything happened. Oh, and I wanna show you my new toy real quick. And it's my latest benchmarking tool. That's actually Phil's joke, I stole it. So I said I was gonna build a gym out in the corner out here. I've started. So you can see it's offset to the right. I still need room for my dumbbell rack over here. And then this wall right here actually is gonna be a yoga wall. Not for me, although I've done yoga with the wife. I kind of suck at it. My wife wants to do yoga and so does my daughter. They go to a yoga studio. I thought it'd be neat if they had their own yoga wall here with all the hooks so they can do their trapeze hanging and stuff. So whatever, I'm gonna go test. Okay, several hours later and quite a bit of interesting data, to be honest. So I'm gonna go ahead and ask Phil now, and you can speak up and say, which orientation do you think performed the best? Horizontal, vertical, plugs up 90, plugs down 90?
I think plugs down 90.
Why do you think that?
Just because of the fact that the vapor chamber section of the cooler is the widest part, and so having the heat pipe section be above it could technically influence the condensation, but I mean...
Makes you wonder if it could return to the plate, to the vapor chamber faster,
yeah,
right?
But the thing is, like, the wick is supposed to work in any direction.
Right,
so.
The wick shouldn't matter. Anyway, okay, so let's go and talk about the results. I'm gonna show you real quick the testing setup. That way, if you guys see anything that you think could be a problem, you can bring it out. I wanna point out these AIO fans are barely turning. They're set to the minimal speed right now because I didn't want any cold air or any warm air potentially coming through here. This is not a CPU test, so there was no real heat being generated in this. The air coming out of here is pretty cool, but I didn't want anything affecting the GPU. Also too, I'm gonna point out my temperature sensor here is hidden behind this box over here where it's not getting any airflow affecting it from either the fans over here or the HVAC here in the room. I did do this later in the test. You'll actually see one of the lines in the ambient temp because I did chart ambient temp so you guys can see the correlation. We've already talked about how that's important. One of them is nearly solid. That's once I did this. So that made me realize I need to build myself like a thermostat box. You know, thermostat housings on a wall have a box that go over them for two reasons. One, so people don't mess with the settings, but two, that way it doesn't get affected by any direct airflow from any of the supply vents blowing on it with colder air to affect the temperatures. So that allows it to have an environment where there's usually some slits on it where ambient air can get into it to make the temperature equalized in there, but also not be affected by airflow. So I'm gonna be building myself one of those boxes to put the end of the probe in, that way it's not being affected by any potential movement. It's a good thing and a bad thing. One, the good thing is it's extremely sensitive. It is a very sensitive temperature sensor. I've already showed you guys that. Any K-type stuff is, it's very scientific in terms of its sensitivity. The downside is because of its sensitivity, if I was to wave my hand across it, you're not gonna see it do anything right now because it's hidden, it would actually potentially drop and then come back. Or if I got too close to it with my body heat, could actually affect it. So I'm trying to isolate that stuff as much as possible. Fortunately, you'll see the max difference that we saw in the ambient temp was just over 1.5 C. Anyway, it'll be interesting when we compare that because I'll tell you right now, the test that actually had the slightly warmer ambient temp was the coldest in terms of the orientations. So that actually brings it even slightly colder if we were to normalize for ambient temp. So if the ambient temp was 1.5 C higher, we can drop that to normalize to 1.5 C down across the board on the GPU temp, as we've already demonstrated in our previous ambient temperatures, how it affects your components, which makes it even that much better. Okay, so let's go ahead and take a look at the charts. Let's go ahead and start with the horizontal position, which is the most common. You might notice that the temperatures seem very, very low. The reason for that is one, the fans were locked at 80% speed on the GPU, not even 100, so we could have probably brought it down a couple more degrees. Two, it's chilly, it's winter time. The temperature here in the room is about 21.5 C. Well, right now it's showing 24 C, but that's because the heater and stuff was on when I was done with the test. But anyway, it was about 22C on average, sometimes bumping 23 down to 22, 23, 22. So it's not very warm. And then 2, it's an open air test bench. You can't have anything affecting the performance of it by adding a variable like the case. So in our horizontal position, there's a fan on the backside, I keep forgetting that. We reached 59C as a maximum temperature. So it's pretty cool, like as you would expect. When we go into the vertical position, which is basically how you would see it in your case, if you had a vertical mount or anything like that, we actually saw it peak 60 a couple of times. So it was actually just a degree, 1 degree. Now you gotta understand, 1 degree is margin of error. 1 degree is run variance, right, between the tests and stuff. It's also important to note that it was not shut down in between each of these tests. I kept it with the same boot, same running. That means all the background tasks and everything were the same for all of these. So it wasn't any sort of a restart update or anything like that that could affect any of these particular runs in terms of variance. I also started the test with the GPU idling at 25C every time. So the GPU started with the same test at the same starting temperature. So it means in between runs, I had to let it fully cool down to 25C before we started the runs again. So I wanted to make sure I pointed that out. Also too, the slope at the end of the run I thought was important because I wanted to see how fast or how slow it took to get back down to 29C. So I waited for it to break the 30C threshold to stop the test. So I'm looking to see if any orientation also slows down its cooling rate when it's not under load. So does it take longer to reach a cooler temperature at idle? So our vertical and our horizontal, really, really close. So already you can just say, it doesn't matter which orientation you put it in. You don't have to worry about your vapor chamber being affected by the pipes being higher. But what about these more extreme type of orientations where we're talking like 90-degree vertical? So 90-degree plug up, which is the pink line, is how I have it right now, as you guys see it on this table. I had the air pulling from the room this way. So it wasn't pulling any air from the system, nothing warming up on the motherboard could affect it. It was pulling from fresh air right here in the open side of the room. Our temperatures actually averaged about 58C. So we're already 2C down from vertical, which is interesting to me because this is actually upside down from the orientation that Phil was thinking would be the better one because of the fact that the vapor chamber is on top of the heat pipes. But what happens if we flip it the other way, which is where we put the plugs facing down? I need to point out too, I was also very, very meticulous in making sure none of the vents up here or on the side or anything were being blocked. So I had built like a stand that was touching the edges. Same thing with the edges when it was going horizontal. Nothing was in front of the fan, nothing was in front of any of the fins. So there was no blocked airflow whatsoever. It was just completely open to the environment. But as soon as we put the plugs down and the heat pipes at the top, Phil was right, this was actually the coldest orientation that we saw. We averaged 56C. So we're talking 4C difference now between vertical mount, like in a vertical riser card that you would put in a case, and something like you get with the SUP-01. This is basically the SUP-01 orientation. Sounds like another freaking Lian Li ad, but it's not. It's just, I wondered when we built that SUP-01 how well that would perform. Now the SUP-01 has other issues in terms of cooling. It's a very compact case. It is pulling air from outside, but then it's got to like cycle it back through in a weird angle to get back to the exhaust fan. So the orientation is good. The implementation on the SUP-01 though is a bit restrictive, as we've already talked about. But I was a little surprised that this is the orientation right here that performed the absolute best. Now, best being a difference of 4C between the worst and best has to take into account the fact that there is going to be, if you look at the ambient temperatures, this one that was best was actually the one that had the ever so slightly warmer average temperature, but it was also the one that had the straight line across it because it was when I put the probe back there. Here's the takeaway from this. None of these matter. None of these are going to make or break any of your performance. They all had the exact same boost clock. On this particular card, by maxing out the power limits and stuff, the boost clock went all the way up to 2745, and by the end of the run was at 2715 every time. So it went 2745 at about the middle of the run, once it sort of equalized, it was at 2730. Once they crossed like 55C, they all dropped down to about 2715 because of the fact that they're using the exact same boost clock or boost table when it comes to temperatures. So it makes no difference whatsoever at all, the orientation, at least with this card. Now let's talk about why people are talking about this. If you recall a few years back when AMD launched its 7000 series GPUs, it was discovered that putting the 7900 XTX, I believe it was the 7900 XTX, in a vertical format was actually causing, orientation was actually causing severe throttling due to temperature. The temperatures were kind of going really high and through the roof. That had nothing to do with the vapor chamber design. That had everything to do with it was defective, and that a lot of the early test samples that we received as reviewers were not properly filled with the amount of wicking fluid that was necessary to get the job done. So when it was horizontal, it was still able to kind of wick through the length of the heat pipes, but as soon as you put it upright, you would get a steam pocket that sort of formed, and then it was like almost insulating so that the vapor chamber material or the fluid was not able to properly utilize the heat pipe. So you were getting really bad hot spots on the die. That was actually a defect in that vapor chamber assembly process, not a vapor chamber design issue. The more important thing here is to make sure that you're not choking off the inlets to your card, whether it's a Founders Edition card like this or a triple fan card. The issue with vertical mount that has people usually talking about whether or not it's bad is how much space is there between the side panel of your case and the inlet for the GPU fans. With cards getting thicker and thicker, and for a while their cases were not really getting any wider. Dual chamber cases have sort of solved this now because they're so deep, but sometimes the fans would only have a few millimeters between the glass and their intake, and the fan blades themselves, which means they're just getting choked off by the amount of volume that they could pull in. That's why you have a lot of case designs now that actually specifically blow air towards the side panel to kind of deflect it back into the front of the case. Now you have cases that are making little scoops on the bottom to make sure none of that GPU heat is making it back to the motherboard and it's sort of evacuating it in a different... Case designs are actually getting kind of fun. But this was something I woke up today and I went, you know what, I want to test this. Actually, it's because of that email I mentioned that I got asking if the orientation was a factor, because they had seen people saying, don't mount it this way, it's gonna be better or worse, et cetera, et cetera. But that all has a lot of asterisks, that has a lot of factors going along with it that are outside of the GPU orientation itself. It's what environment is the GPU in that can affect the orientation positively or negatively. I think, personally, my choice is I would leave it standard horizontal. So if you have your motherboard like this, and then I want the card sticking out like that. This is the new 40 series thing that makes me say that, because as you know, these are blow-through style cards where they're trying to reduce the amount of restriction as possible. So every 40 series card now in the back half tends to have air going all the way through it. If you put it vertical in front of your motherboard, you have now made the amount of space for that air to escape get very narrow depending on how far away your vertical mount is. If you have a good gap between the motherboard and your vertical and your graphics card, then it probably wouldn't be a problem. But when I had the Inwin 925 and I did my 3090 in a vertical and it was real close to the motherboard, I actually saw worse temperatures than if I had it horizontal, allowing the air to just free flow up to the top of the case to be evacuated. So I was actually hurting the performance of the GPU by the proximity of the card to the motherboard. Had nothing to do with the orientation of the card at all, with the exception of the fact that now you have to think about air flowing all the way through the card, which wasn't something you had to worry about before. With axial fans, all the air escaped the perimeter of the card. So I would actually rather have the fan or the GPU against the motherboard and have some of the air coming out the bottom be somewhat choked off by the motherboard itself than having the larger surface area of an entire fan blow-through design being choked off by it being too close to the motherboard. Although it can help cool like the PCH, maybe the RAM and stuff like that, at the cost of your GPU performance in terms of its thermal performance being impacted by that. So it's really an orientation and a case design layout than it is the GPU cooler design when it comes to orientation. So I hope this video helped teach you something. I've seen this discussed a lot. I still see comments of people saying, why are you going vertical mount? That's bad for your GPU. It's just not true, at least not in this instance. Of course, I didn't test every single GPU on the market, but I think our results would be pretty consistent, that it's really not gonna matter. I was a little surprised though, that the plug down orientation, right? Plug down, yep, the blue one, was the one that gave us the most consistent average lower temperature. 4C, that's outside the margin of error. That's outside run variance. That's actually measurable. But literally would not be noticeable at all in your boost clocks, your FPS, or any of that sort of stuff. It's just it'd be a min-max stat, that's it. All right guys, thanks for watching. Sound off if you learned something down below, subscribe if you're new around here, and as always, we'll see you in the next one.